Welcome to Unit 2, Lesson 6, Modeling with Formulas. Today's lesson is all about isolating. You will be expected to rearrange formulas today so that one particular variable is isolated. It's crucial that you can perform the opposite operation in order to isolate properly. Opposite operation. So let's just start with a practice question here. Solve for x. This is not a formula. Today we're talking about formulas. This is not a formula. This is just an equation. But let's practice isolating. Solve for x. So the question says solve for x. That means when I'm all done, I should have down here like x equals 5 or something. Solve for x means isolate x. What do I do first? Well, I'm going to have to distribute that 3 in first to the bracket. That gives me 3x minus 6 in red. That's the new, everything else is the same. Okay, now what? What do I do? Remember, when we are solving or isolating, we're doing the opposite of BEDMAS in the other direction. So first I'm going to do subtraction and addition. So I'm going to collect anything that I can with subtraction or addition. And I have got these two constants here, and I can collect those. They'll give me a negative 5. So what are we going to do now? We've got an x squared here, an x and an x. We've got to collect like terms, right? But we can't collect these x's. Remember this is a squared shape and this is like a single rectangle shape. We can't collect these two. So what we are going to collect, we have a few x terms. There's more than one of them. There's an x here and an x here. So let's collect those first. So I'm going to start by taking this 3x. I'm going to move it over to the other side. And the way I move it over is the opposite operation. So I'm going to subtract 3x. That gets rid of these. But then I have to subtract 3x on this side as well. And when I do that, interestingly enough, they're gone. My x's are now gone. I have just the minus 5 is there, but these are all gone. And that's good because we want to get down to one x, a single x. So that really helped us out. So now what? We are still collecting like terms. We're still in the subtraction and addition part here. We're still collecting like terms with subtraction and addition. So what like terms am I going to collect now? I've got constants. I've got a constant on the left and I've got a constant on the right. That means we'll move this one over, and that way I can leave my x squared where it is and it won't cause me extra steps. So I'm going to move the negative 4. I'm going to move the 4 over by subtracting 4 from both sides. That gives me negative 9 equals negative 4x. So I can't collect any, there's no more like terms for me to collect. So I'm done with the subtraction addition. Now I'm on to multiplication and division. In order to isolate the x, well it's an x squared, in order to isolate it, I'm going to have to divide. I'm going to divide both sides by negative 4 to isolate the variable. So once I do that, these two will be gone. They'll cancel each other out. That's the opposite of multiplication. Right here, this is negative 4 times x squared. So I have to divide it to get rid of it. I divide this side. I've got a couple of negatives there, so I can clean that up a bit. I've got 9 over 4 equals x squared. It's almost isolated. I'm on the E for exponents. How do I get rid of that exponent 2? What's the opposite operation of squaring? Square root is the opposite operation, so I'm going to take the square root of both sides. The square root of 9, I know what that is. The square root of 4, I know what that is. So when I take the square root of a square, these two cancel each other out, and I'm left with my answer of 3 over 2 equals x. Now, technically, it's plus or minus 3 over 2 equals x, but for all our formulas today, everything needs to be positive. So it's 3 over 2 equals x. So that was solving for x without it being a formula, just an equation. So let's try some formulas. We've got a formula, v equals d over t. And that represents velocity, that's the v, as distance over time. It's the formula for speed. And you may be doing this in science. Rewrite this equation isolating d. I want d to be isolated. Here's a d. So I've got to get rid of this t. I have to get rid of whatever else is on the same side as the d. So I don't want this to be here. I want this to be gone. I just want d. How do I get rid of the t? Right now, that is d divided by t. The opposite operation is to multiply by t. That would be the opposite of dividing by t. So that's a kind of crooked T. Try to make your T's not look like plus signs, because then one day you might confuse them, and maybe make them a little bit curvy if you can, so that they don't look too much like a plus sign. Okay, what am I doing now? I've got D divided by T times T. So the reason I did this would be so that they would cancel out, but I also have to multiply by T on the other side. So I've got T times V equals D. So D is isolated. That's it. Because I have two variables here, I can just squeeze them together. I don't need the multiplication sign in between them. The multiplication sign is assumed between two variables. So there's a formula saying that distance is equal to time times velocity. Time times velocity, yeah. Okay, equation 2, example 2. This equation is the equation of a line. We need to isolate M. So here's my M. I want to keep that. I want this gone, this gone, this gone. So I have an order that I have to follow for what I'm going to get rid of first. The first thing I want to get rid of is the addition subtraction. That's the B. So right now I'm adding a B. The opposite of that is subtracting a B. So Y minus B. So these, on the right, these two will be gone, B minus B. On the left side, I've got Y minus B. And on the right side, I have M times X. I'm trying to isolate M. So the next thing I want to get rid of is the X. I'll have to divide both sides by X. Divide both sides by X. These X's on the right will cancel out. And on the right hand side now, all I have left is an M. And on the left, I have some variables that I really can't simplify at all. I can't tidy these up or change it in any way. It has to stay like that, Y minus B over X. Example 3. All right, this one's a little more complicated. All of you know that there's a difference between centimeters and inches. And there's a formula that we can use to get an approximate value to convert them, inches into length of centimeters. So there are two ones. Inches are imperial and centimeters are metric. So we have to convert between them. And you're going to need this one in your homework. You have a couple of questions where you have to do this conversion. So when you get to question 3, you can refer back to example 3. Use the formula to find the number of centimeters in 6 inches. So 6 inches, I want to kind of figure out, well, how many centimeters is that? So I have a formula for it. Let's use the formula. I'm going to start by writing out the formula. C equals 2.5 and then a capital I. So where's the 6 going to go? Is the 6 going to go in for the C, or is it going to be substituted in for the I? Well, the 6 is in inches, so it's going to go in for the I. So 6 equals C equals 2.5. Always substitute using brackets. 6. So what's 2.5 times 6? It's 15. So C equals 15. So what have I got here? What does this mean exactly? So I might need to reread the question to figure out what I did to make sense of it. And I'm going to put a sentence out here just so we all understand what we found. And that's what we found. That the C equals 15, so 15 centimeters is equivalent to 6 inches. Next example, we have, this one's a little different, 3 feet. 1 foot equals 12 inches. Okay, look at the formula I've got up here. The formula I've got up here, there's nothing about feet in it. So I can't substitute the 3 in for I or in for C because this is feet. So I have a conversion here. 1 foot is equal to 12 inches. If 1 foot equals 12 inches, then 3 feet would equal how many inches? What do you think? If one foot is 12 inches, then 3 feet, 36 inches. So now we have something we can sub in. So let's go back to our formula. Our formula is C equals 2.5 times I. And I've got a number here, and it's an I. So C equals 2.5 times 36. and that is 90. C equals 90. So put that into a sentence. I specifically worded this sentence kind of the opposite way that I did the first one, just changing the unit. So I started with 3 feet is equal to 90 centimeters. Over here I said 15 centimeters equal to 6 inches. So we started with 3 feet and we ended up with 90 centimeters. So those are the only examples. The last thing I just want to talk to you about is this question in your homework. This is question 1, and it says above it, for help with question 1, see example 1. Now that means the example in the textbook. So you flip back in your textbook pages and you go to example 1, and it can help you if you get stuck. But really what I want to look at is, what is question 1 asking for? Rearrange each formula, so here's your formulas, to isolate the variable indicated using pencil and paper. What are they talking about? Okay, when they say using pencil and paper, they just mean writing it down. So just ignore that. Isolate the variable indicated. So over here we've got P equals 4S, 4S. So what the question is saying is they want you to isolate S in this formula here. They want S to be isolated, and then over in brackets they're saying this is the formula for the perimeter of a square. So this last section is just telling you what you're starting with, and then they're asking you to isolate whatever is in this column here. That's what they want isolated from these formulas. So I just put that in there because it's kind of a common mistake that students have, or a question that they have. They don't really understand how the question is worded. It's not worded very well. So that's it. You've got homework on the bottom of your handout to do, and as always, you let me know if you have any questions. I'm here.